Hey there, future electrical engineers. Let's talk resistors. They're like the unsung heroes of the electronics world. Tiny but mighty, they control the flow of electricity. Without resistors, our gadgets would go haywire. Resistors come in different sizes and strengths. They're color-coded so we know how much they resist electricity. This resistance is measured in ohms. Think of resistors like speed bumps for electricity. A big resistor is like a big speed bump, slowing down the flow a lot. A small resistor is like a little bump, slowing things down just a bit. Resistors are essential. They protect sensitive components, divide voltages, and help circuits work properly. Next time you use your phone or computer, thank a resistor. Want to know if a resistor is doing its job? Use a multimeter. It's a handy tool that measures electricity. Here's how to check a resistor. First, set your multimeter to measure resistance, usually marked with an ohm symbol. Now, turn off the power to your circuit. Safety first, always. Touch the multimeter probes to the resistor's leads. The reading on the multimeter should match the resistor's value based on its color code. If the reading is way off or you see OL for overload, the resistor might be broken. Time for a replacement. Remember, a working resistor is crucial for a healthy circuit. When resistors are connected in series, it's like making electricity go through one speed bump after another. The total resistance increases. To find the total resistance in a series circuit, just add up the values of each resistor. R total equals R1 plus R2 plus R3 and so on. See? Simple math. In a series circuit, the current or flow of electricity is the same through each resistor. Keep that in mind. Section 4. Resistors in parallel teamwork makes the resistance less. Connecting resistors in parallel is like giving electricity multiple paths to take. This actually decreases the total resistance. Calculating the total resistance in parallel is a bit trickier, but here's the formula. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on. Don't worry too much about the math. The key thing to remember is that the total resistance in a parallel circuit is always less than the smallest resistor value. Cool, right? Section 5. Important stuff to remember about resistors. Working with resistors? Great! Here are some things to keep in mind. Power rating. Resistors can get hot. Make sure you pick a resistor with a power rating that can handle the electricity flowing through it. Tolerance. Resistors aren't perfect. Their actual value can vary slightly from the stated value. Check the tolerance marked as a percentage to see how much the resistance might differ. Safety first. Always turn off the power before working on circuits. Electricity can be dangerous, so be careful. That's it for resistors. They're little components with a big job. Keep experimenting, keep learning, and most importantly, keep having fun with electronics.